Find out the Laplace transformation of f of t divided by t. Let us call it by a different name called g of t. Okay, so you can now understand. For example, let us say x plus 1. Okay, x plus 1 is f of x. Okay, that is your function. That's the first example. Second example is why only x plus 1? That's what you are asking. The second question that you are asking is that x plus 1 divided by x. Do you agree that x plus 1 is a function of x? That's the question. Do you agree? Yes, I agree that x plus 1 is a function of x. That's over. Then you are asking another question. Do you agree that x plus 1 by x is a function of x? Then once again you say that yes, we agree. Okay, so that is there. Then third question you are asking is, suppose if you are going to take the equation number 1, that is this one, divided by x. Equation number 1 is x plus 1 divided by some x that you are having. Do you want to call this also a function of x? Like that I am asking the question. Again you say it is yes. So what you understand is that g of x is nothing but this f of x divided by x. So it is up to you how do you understand. This alone you consider as a function of x, or the entire thing you consider as a single function, or you can consider that this function is separate and 1 by x is separate and multiplication is there. You consider it as another function. This idea only is going to happen here. F of t is function of t. Now you are dividing by t. Now, do you agree that that is another function or not? That's what we are asking, and we are saying that yes, it's another function. So if f is one function, then g is also another function of t, because we are just dividing by t here. So it's only kind of renaming. This renaming is for easily we can group them and then get the answer. Okay, so how does it help you to group? So let us see how we are going to do that. We can now write down this f of t as by doing cross multiplication t times g of t. This is the rearrangement that you are going to have if you are going to call. This is what we are going to call by the name g of t. So if this is the case, then what happens is you take the LT on both sides, taking the Laplace transform on both sides. So you will be getting like this: Laplace transform of f of t would be equal to Laplace transform of t into g of t. So you can write like this. Now you understand. Do you get the answer or not? Like that you have to think. Now what is your answer? Your answer will be obtained if you get Laplace transformation of g of t. Please see this. What is your objective? Our objective is get the Laplace transform of f of t by t. But what is f of t by t? I am calling by the name g of t. So I want the Laplace transformation of g of t. Can you get Laplace transformation of g of t? You ask this. Can I get Laplace transformation of g of t? The answer is yes, because just now we were explaining that this multiplication will not trouble you. You simply forget about this t here, and then this t will be converted to differentiation. So that means Laplace transformation of g of t you first do, then perform a differentiation. So that means we are going to get the answer. So we already know what is going to happen in future, and therefore based on this idea we are going to proceed further. So now you know that what is the how do you write this multiplication factor? This multiplication factor will be converted to -1 multiplied by the first derivative. It is first derivative because this is t to the power 1 here. So this is therefore -1 to the power 1 first derivative of Laplace transformation of g of t. That's what you have, and on the left side what you have is Laplace transformation of f of t, which we can write down as f of s. Similarly here also we can write down. Of course now we will write down. So L of f of t is written as its capital letter version. So capital letter version is written right minus d by ds. Here also L of g of t is what? Capital letter. So here also L of small g is nothing but capital G of s. So Laplace transformation of the small letter is represented by its capital letter where the argument is transformed to the s variable. So finally we got this result here. Okay, and now you already know what is to be obtained. We are interested to getting the Laplace transformation of g of t, which is nothing but we are interested to know what is g of s, isn't it? So that much should be clear, otherwise you do not know how to re-energy. I am interested in getting what is g of s. Do you have the answer or not? We have it, but unfortunately there is a d by ds. If you can remove somehow this d by ds, I am going to get the answer g of s. Now the question is, how will you remove this d by ds? D by ds can be removed by performing the integration. Because there is a differentiation, you perform integration. Integration of the differentiation cancels, and then actually d by ds can be removed here. So therefore, if you want to remove this d by ds, you have to perform an integration with respect to s. That's an idea that we have, and therefore we can now proceed like that. So integration of the left hand side. So let me write down like that. Integration of the left hand side should be equal to, minus is there, okay. Integration of the right hand side is integration of d by ds. Then we have g of s ds. There is an important point here. Differentiation is with respect to s. Integration is with respect to s. Then only it will cancel. Okay. You should not do it different variables. Okay. Differentiation with respect to s means integration should also be with respect to s only. Only then this will be cancelled. Okay, that's all about it, and then we can try to simplify this little bit. But here comes an important property. You need to know a property so that you can simplify this expression. So let me explain that now. Okay, what do you want? Let us write down, otherwise we'll forget. So aim is that we have to get the Laplace transform of f of t by t equal to how much? Which is nothing but, let me again make it clear, what do you mean by that? We are interested to ask the question, what is this? Which is nothing but g of s is how much? Okay, g of t is nothing but f of t by t. We are asking what is L of g of t, which is nothing but g of s. So we are asking what is g of s, and g of s is available here somehow. Okay, so this is our aim. So keeping this aim, we are working actually. So let us therefore write down this expression. This minus I will bring it to the left hand side and write down minus integral f of s ds would be equal to, so integral and d by ds will get cancelled. Okay, that is clear to you, or we can say that this ds cancelled, then integral of d of g of s will give you g of s, isn't it? That's all about it. So now you see, we are asking the question, what is g of s? Answer is looking here. The answer is looking like g of s is that much. In principle, this is the answer, but you have to take care of this even one step further so that things are comfortable and convenient. So for that, you have to use this property, which I have earlier explained, sometimes in the beginning of the class on Laplace transformation. I told you that there are two important conditions are there. First condition is that in the limit of s tending to infinity, the function f of s should be 0. The second condition is in the limit of s tending to infinity, s multiplied by f of s, s multiplied by f of s should be a constant. These two conditions are, what are these conditions? These are the two conditions to be satisfied by every Laplace transform problem. Okay, so when f of s represents Laplace transformation of some function, the answer should satisfy this property. Two properties should be satisfied by every problem. So this is a demanding requirement, and the meaning I have already explained in that previous classes, that this particular condition we are trying to impose on the left hand side, because on the left hand side you have an integration, and there we are going to use this property that in the limit of s tending to infinity, f of s is 0. How to use that? Let us see. How to use is very easy. The idea is like this. There is a minus here. This minus of integral is nothing but 0 minus integral f of s ds. right hand side is same. You see what I have done, left hand side, minus integral f of s was the left hand side. I am writing 0 minus integral f of s, both are same, right? This is nothing but you can ask the question, why am I writing 0? That is your doubt. That 0 is there here. 0 is there. 0 is nothing but f of s only in the limit of infinity. It is a necessary condition that in the limit of s tending to infinity, every f of s has to go to 0. If it is not going to 0, that expression has to be totally rejected. We cannot accept that expression as the solution to a problem. So that is the condition. So because of that reason, so a 0 can be written down here, and which is nothing but integral from s to infinity. So I am now working out in the what you call the reverse direction. Okay, you can understand what is actually happening. This 0 is connected to this infinity. See this one. This 0 will come only when there is a s approaching to infinity. So I am trying to bring that infinity in the limit here. So now I can write down that this is f of s ds equal to g of s. So there was originally minus sign. This minus sign I want to absorb by putting some limits here. So now what do you understand this one is that you are going to perform some integration, and I am going to put the limits here. When I am putting the limit, you are going to substitute an infinity here. So when I am going to substitute an infinity, this f of infinity should be going to 0. So this is a demanding requirement for the existence of the Laplace transformation. So that has to be incorporated. That is the reason for this. So this is the place where some clarity should be required for you. Otherwise some people will get confused. So this minus is now absorbed here. You understand what is this absorbed? F of infinity, which is coming here, and then minus s has to be substituted here. And now you understand one more confusion, little bit confusion is there. What is that confusion is, let me write down here. It is not a real confusion, but it is apparent confusion. Let me write down for clarity. I have something like this. X square dx I have. And now I am saying that x equal to x2, x equal to 3. This is how I want to do some integration. If you close my hand on the limits, there is no trouble. There is no trouble because you can always write down x cube by 3. But confusion is x equal to x means what is the meaning? X equal to x, there is, this doesn't look nice. And then you can understand that x comes into picture because there is a x here. That's fine. But this is looking odd here. It doesn't look nice. Something is wrong because x equal to x is not correct. So this way of writing, this integration looks somewhat not comfortable, or therefore technically this is not correct way of writing. Instead of that, you can do like this. Since this is giving confusion, you better write down as y square dy and then say that y equal to x to 3. Both are same, right? Now you see that y equal to x, y because this is y, there is a y here. So this becomes y cube by 3. When y cube by 3 comes, you can substitute x on one limit and 3 on another side, upper and lower limit. If you write like that, this is correct. So you understand that this is little bit confusing appearance is there. That's why I am saying this is not correct. So let me therefore put that. So this portion, something like this way of writing down is not correct. So instead of this, how you can rewrite? You can rewrite that way. That way means I am putting y. Or alternatively, you can also write down that this is an x prime square dx prime. I am simply changing this to the prime here, and here I can write down that x prime equal to x to 3. So if you want to write like this, this is fine. So what I am trying to say is that x can be changed to some other letter y, or if you don't like y, I want to retain x only means you put a prime here. X prime is a different variable from x, and now it is clear that x prime will start from x to 3, y value will start from x to 3, x value will start from x to 3 means little bit confusion. So therefore this version we want to avoid. This version is okay, good, but in the disadvantage is I have to totally go to a new variable. This is little bit more preferable because I try to retain my original appearance, x here, here also x here. Only thing is just to say that it's a different variable, putting prime is more comfortable. Now for that reason, for more comfortable and convenience, for that reason, we are going to put some prime here. That's all about it. Let me put a prime here and then get the final answer. I'll say like this, it's an integral f of s prime. So I don't like this s here, not a correct, technically correct. So I am going to change this to the prime notation here, this prime here. And now we can say s prime equal to s to infinity, and that would be equal to g of s. So this is the answer. Finally, we are getting the final expression. Final expression means we are asking, no, what is this g of s? What is g of s means L of g of t. But what is g of t? G of t is f of t by t. So L of f of t by t is nothing but g of s. And g of s is given by this expression. So our conclusion, main conclusion should not be forgotten because of the intermediate steps. Main conclusion is, if you want to calculate this, you don't have to worry about this factor t. This factor t, you can just forget about it, and then we have only f of t. For that f of t, you take the Laplace transform, I get f of s. That f of s is there here, you integrate. So now you understand that the factor 1 divided by t appears as integration. Earlier, when you multiply by t, it appears as differentiation. So this is what you have to finally understand. The final understanding is like this. T times, if you are going to have t times f of t, if it is like this, then this will be looking like differentiation with respect to s, whereas 1 by t multiplied by f of t, if you are going to have a function like that, this will give rise to integration with respect to s. So integration with respect to s, differentiation with respect to s. So this is the two topics that we covered now. Okay. So now this is important because integration means you should also know with respect to what. That's very important. Integration is with respect to the s variable. Prime comes because the lower variable is s itself. Therefore, to avoid that some kind of confusion, we will put the star here. So this is the expression we are going to use to get the answer to the Laplace transformation of sin bt by t. So the answer is quite simple, and right away we can get the answer by using this equation. So let us do that. So let me therefore erase this portion.